cohesive behavior. Cohesive behavior means they can attach to each other and actually can control the temperature. If the environment temperature is a lot, your body temperature will be 98 Fahrenheit. If the weather is cold, your body temperature will be again the same. It will not fluctuate based on the environment's temperature. This is the reason that God, the great God, has created our body mainly from water, because he was smart. He knew that our body, if it was anything other than water, for any climate change, our body temperature would jump up and down and we would die. But this is not the case. We have water. Water has a high heat capacity. We can write down high heat capacity. Means it can control the temperature. Control the temperature without changing a lot. Upon freezing, it expands. So you see in the cold weather how the pipes, water pipes can burst. And it is a good solvent. Another reason that our body mainly is water or blood, because our blood sugar, blood hormones, everything can dissolve in it. So these are the reasons, properties of the water you need to know. Slide number 6. And it has also cohesion. As I told you, the water molecules can attach to each other. And the water molecule can attach to other molecules. When you pour the glass of water with water, so the water will attach to the glass molecules. That is called adhesion. But the water molecules that attach to each other, that is called cohesion. So when they connect to each other, that's cohesion. When they attach to another surface, that is called adhesion. AD. You need to know these differences. And also, this cohesion connection of the water molecule causes to it has a high surface tension. Means it cannot easily break. What is the meaning of this mosquito? Animal can sit on the surface of the water, so the water can tolerate the weight because they have cohesion. They connect to each other, so they cannot easily break. So this animal can actually survive, stay in the surface of the water of the ponds, rivers, something, and they can live there, right? So everything is water, and we have this session for you today. You need to know adhesion is when the water connects to another molecule. This chapter is easy and interesting chapter. So you see, because of this adhesion and cohesion, the water is able to climb the body of the trees and go to the leaves. And all of the part of the leaves will enjoy from this water supply. So this is the how the water can moderate the temperature. It absorbs the hot air and actually store in a cooler air. So heat is a kind of temperature. We have a kind of energy, sorry. We have different types of energy. When you have energy that moves the things, that is called kinetic energy. The energy that increases the temperature is called thermal energy or heat energy. The unit of the temperature is calories, CAL. It is the amount of the heatness that can increase 1 gram of water temperature by 1 degree of centigrade. And we have a bigger unit that is called kilocalorie. That is about 1,000 calorie. Another European unit for that is joule. Each joule actually is less than 1 calorie, because 1 calorie is about 4 joule. You need to know. And then we have kilojoules, that is 1,000 joule. The specific heat is the amount of the heat that must be absorbed or lost from any substance, material, for 1 gram of substance to change 1 gram of centigrade, once the centigrade degree of temperature. That is called a specific heat. The specific heat for water is 1 calorie per gram. So you need to know slide number Actually, 15. Water has a high specific heat, means it cannot easily change the temperature because of the climate change and environment change. As I told you, when the heat is absorbed, the hydrogen bonds break. For example, when you boil the water to make some tea or coffee for yourself, some water will evaporate because these hydrogen breaks are weak, dotted line, non-covalent, they will break and the water from liquid form will change to what gas form. So our body has a large amount of water, so can absorb the temperature. Here you will see different places, and actually when we evaporate, we have a cooling effect on the wall surface of our skin when our sweat is evaporating. So it works for us, works for animals and every living creature. So what is the other terms here in this chapter? Solution is a even homogeneous mixture of liquids and some substances. Solvent is only the liquid part that can dissolve the solute or the substances that are solved in the solvent. An aqueous solution means the solution that is water. Aqueous means water. So you need to know the meaning of these four words in slide number 24. For example, when you put the table salt in the water and mix it, stir it with a spoon, the sodium chloride atoms will separate. Chloride will be surrounded by some molecules of water, sodium as well. So then the salt will be ionized and it disappears, but the taste of the water will be salty. This separation and surrounding by water molecules is called hydration shell. The water will be like a shell cover and surrounds the ionized atoms. Hydration shell means water shell. So water in this way can dissolve many other things, not only salts, the proteins, the vitamins, the hormones in our body. Another thing is that if the molecules are able to be dissolved in water, like salt, like sugar, then means they like water, that they can dissolve in water. So they are hydrophilic. When the molecules cannot dissolve in the water, they hate water. They are hydrophobic. Oil, you never can dissolve in water. If you stir it, it will separate, but again it will collect in the water. So oil molecules are hydrophobic, but they hate water, but they love fat. Oil can be dissolved in fat, so they are lipophilic. Phil means love, phobia means hate. And opposite is hydrophobic. When something is hydrophobic, it is lipophilic. So you need to add this to the slide, number 29. Can you see whatever I type for you? Okay, good. So, if something loves water, is hydrophilic, it hates fat. So I correct it, it's lipophobic. You correct. Hydrophilic is lipophobic. If something hates water, it loves fat. Because these two are two opposite. But sometimes we have molecules that hate water and oil at the same time. Those molecules with dual interest are called amphipathic. Amphipathic means it's both hydrophilic and hydrophobic. The example of amphipathic is soap. When you wash your hand with soap, the dirt on your hand is oil. And the soap from one end that is hydrophobic will connect to the dirt. From the other end that is hydrophilic will connect to the tap water. So, in this way, the dirt will be removed from your hand after you wash it with soap. So, soap molecules like and hate water, like and hate oil at the same time. They are amphipathic. You need to learn this. Most of the chemical reactions in our body is because of this water chemistry. And if you add all of the masses of the atoms in a molecule, that is called molecular mass. Number of molecules are measured in mole. One mole always is 6.02 to the power of 23 of 10 molecules of any molecule. This is called Avogadro number. Avogadro number that you may know about high school. So, 1 Dalton gram is 1 mole, Dalton. And molarity is a bigger unit that shows how many moles the solute will have in 1 liter. These are chemistry from high school. So, here is just something that you can have a self-study. And here you will see that in hydrogenic bound, always one side is hydrogenic atoms, hydrogen atoms. So again, you will see the picture of water molecules. That is a polar molecule. There is an electricity can pass through the water. So the water molecule can ionize H2O to H and OH, hydrogen and hydroxyl. In a normal pure water, clean sterile water, these are equal 50-50%. If this hydrogen goes up, the pH comes down and it is acidic. If OH goes up, the pH goes up and it is called basic or alkaline. You know that the neutral pH is 7 and pH is between the 0 to 14. It is the calculation that you measure the amount of acidity. I just write here pH is equal of minus log of hydrogen atoms. This is the pH here. Actually, we have different equation. Where is it? This is the. So, a student, if pH is between 0 to 7, under 7 is what? Acidic. Above 7 is what? Basic. The less the pH, the more acidic. The more the pH, the more basic. Acid is anything that increases the hydrogen or proton. Proton. The base is anything that reduces the hydrogen or proton. Hydrogen or proton. For example, your stomach has lots of acids to break the food, digest the food. Our blood is a little basic. Our natural blood pH is 7.35 to 7.45. Average is 7.4. You need to know this. So our blood is not neutral. It should be a little alkaline, basic. You need to know this amount, even if it's not in your slide. So here is the pH. And here is what I explained for you. Have some idea the battery of your car is acidic. Lemon juice, beers is acidic. Bleach and this stuff, ammonia for cleaning the shelves and the kitchen stuff are what? Basic. Your saliva is a little acidic, your stomach is acidic, and your blood is a little more than 7, which is what? Basic. So, how we can have the blood pH stays in this range? 7.35 to 45, and it should not go above this and come below 35. How? Because of some mechanism in the bodies that are called buffers or tampons. These are the molecules that control the change. Don't let our blood pH to goes up or high. Kidney and lungs, in anatomy physiology, we teach works I teach as the buffers. Kidney and lungs. Or some molecules such as bicarbonate and carbonic acid. Bicarbonate and carbonic acid. You know the oceans are going to acidify because of the amount of these carbonic acids increase. You need to know that is not good, but the seawater releases some hydrogen and actually it changed the ecosystem, and that's it. This is a small chapter. So chapter is finished. Ask me a question, please, if you didn't get any part of the chapter. That then I go and check your attendance. Any question?
Is this PowerPoint going to be updated? Because there were a lot of things that you were going in and tweaking. Is this one that you were messing with going to be updated?
Yeah, this is from publisher. It's not my PowerPoint. Why it's not updated? Whatever the publisher is updated. Okay. No, no, no. I didn't update the PowerPoint. What do you mean by update? Did I change the PowerPoint?
No, there were just like a couple slides where you were like changing a few words, and I was just wondering if.
Oh, no, 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 no. I don't have board. I don't have whiteboard. So where can I write for you? Huh? You're Eduardo?
Yeah.
Oh, do you want me to write in my forehead for you? So I should write somewhere, right?
All right. Yeah.
Yeah, this, if you have in the in-person class, I will write for you on the whiteboard. But you
Sure.
understand why I write there, that you make you able. I can write in the chat box, but I need to go back and forth. You
Okay.
understand? So it's not anything about updating the slide or something. It's like I am writing for you on the board. You understand, right?
Yeah.
Any question about chapter? Any of you? Okay, I check your attendance right now. Okay, Huang, do you remember last class I told you the study guide is the discussion post? Do you remember? Did you come, Kai Huang, to the first class or no? Huang. Okay, so I told you I didn't delete the slide because some of you are busy, don't have time to study the book. So you need to know which part are important, right?